Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today, we will look at using random access files within your application. In one of our previous videos, about 6 months ago, we looked at power collections. We're going to look at something similar today, the technology of which has been around for a long time. These are random access files. What we have here on screen at the moment is a small text file containing randomly generated information we're going to put into a random access file. We're going to store this information, first of all, in a collection for each record, and then save it into our little mini database. So what we need first of all is a collection in which to store it. So here we have created a user-defined type, which is going to contain the columns in our record. A first name, surname, street, city, eye colour, blood group, and email address. Now, as it's a user-defined type, the strings we have in here have to be of fixed length. So, as we're going to treat this like a little mini database, we'll need some variables to handle it. So we've created 3 local variables, one for the database name, one for the database handle, and one for the input file. The input file is going to be the little randomly generated text file we saw a moment ago, which contains a list of tab delimited records. So the first thing we'll do is we'll give our database a name. We'll call it DB Customers, and we'll give it an extension .dat. The extension isn't particularly important. I'm just using .dat to differentiate it from plain text files. Now I'm going to create some more local variables, which are going to be used to help us access this database. I'm going to create a record counter, which will be a quad, a total number of records for the total number of records in the database, a user-defined type based on the type we created earlier, and an output file. So what we want to do first of all is we will want to make sure that the file we're talking about, the DB customers, does not exist. So we have a simple try-catch block here to kill the file. Just erase it from the disk. Having done that, we'll need some functions. These will be functions to do the obvious things like to open the database, to close the database, to read and write from the database. So the first thing we'll want to do is to open our database for writing. Now, as we may be wanting to open several of these files at some point in the future, we're going to call an open random database function. This will open the database of our preference and will return the handle of the database. And we will use this handle to make any access to the database to add, delete, or read information. The first thing we need to do is to create this function. So the function is taking one parameter, in this case, the path and the name of the database file we wish to open. Now this is going to be a very straightforward and very short function. Its purpose is to open the database and just to return the file handle. So I've created 2 local variables, one for the file handle and another one to specify what the record type is going to be. In this case it's going to be a user-defined type for our customers. So just like opening any file, we can use the free file command to pull back the next available file handle. We're going to embed our request in a try-catch block so that we can trap any errors. So should anything go wrong, we're going to return 0 as the file handle. In order to open a file as a random access file, all you need to do is use the open command with the name of the file, which also includes the path, mark it as for random, specify the file handle, and then use the len command, the length command, to specify how many bytes it will actually contain. So we can quite easily do this since we have prepped a variable for the user-defined type. And using the len command on that returns quite easily the number of bytes in that record. And assuming that does not error, we can then return the handle, like so. So now that we have successfully opened the file, we can leave the file open while we perform functions upon it. So since we've returned that file handle, we want to test to see whether the file handle is greater than 0 or not. If the file handle is 0, then we fail to open the file. and if that's the case, we'll just push a message out to the log to say that the database failed to open. So having got the file open, our next task is actually to read the flat text file, which is tab delimited with the randomly generated data in it, and for each record in that file we want to populate our database. So we will use our input file variable to pick up the path to where our data lies, and then we will create a function whose job it is to take all the information within that flat text file and push it into our database. We'll call that populateDB. We're giving it the database handle, and we're giving it the name of the input file. So here's the skeleton of our function, taking in the two parameters, the database handle as a long, and the input file path and name as a string. Now we know we have a number of columns within this file to read in, and we want to put them into the right place. So what we'll do, first of all, is we will create a local variable, which is a user-defined type, which is based upon the global type we declared earlier. We'll call this one uCustomer. And as we're going to be reading a file, we'll want a file handle. And as we've done before, we will get the file handle using freefile. Now again, we want to trap our errors, so we'll have a try-catch block. If there's some kind of error, we would want to return some kind of value. I think in this case, if it fails, we'll return a false. So if the value comes back as false, we'll know that we failed to populate the database. If all the instructions we're going to do work, then we'll return a true. So how do we go about reading this information out of the file? Well, the first thing we'll have to do is to open the file. This is very straightforward. We just use the open command with the path and the name of the file for input, as the handle we've just picked up a moment ago. As we're going to be reading each record within this file, we're going to use the file scan command to pick up the total number of records. And we will just declare this new variable at the top. So now that we know the number of records within our raw file, we can actually do a for next loop to loop round each record and to pull it in. So we're going to use a long count for the record counter from 1 to the total number of records. And within this loop, we will read in each record into one variable. So now that we've got the data into the string, what do we do with it? Well, let's have a quick look at the data again. The data is comprised of a header telling us the names of the columns and data lines. So obviously the first line we read in will be the header line. Now from that we can be quite clever here and pick out what the names of the headers actually are. So we'll do a test on the line count. And if the line count is 1, then we know we're reading the header line. So we're going to store that header line into a new variable called strHeaders. Now as well as storing that, it would be useful since in some cases the data within the file may move around, the columns may be reshuffled at some point in the future, so we'll want to pick up where each of the columns actually sits. Now there's a function in our file handling library which does this quite nicely. If we designate a variable being a long, which is going to handle the column number where the first name is going to appear, we can use the fun parseFind command and give it the data line, the fact that the file is tab delimited, and we're looking specifically for the column which is headed first name. This will return the column number that the first name is actually in. So in this case that will be column number 1. If first name was in the 10th column, it would return 10. So we'll do the same for each of the columns we're interested in pulling in. And we will store the value of the column number in a unique variable. So we will set all those variables up at the beginning of our code. So now that we know the column that each of these are actually in, for the other data lines where we actually have data as opposed to headers, we can process them quite happily. And we want to put each of these records into our user-defined type. So we're going to use the prefix command to save a little bit of typing. The prefix command just puts this string at the beginning of each subsequent line. So this way we can use the first name element of our user-defined type to be equal to, and we'll use the parse command here to parse up our data line. We're telling it it's tab delimited, and we're telling it the specific column number. This way we're not hard coding the column number in here, so that should the file actually change, as long as the header line names do not change, then our program will still work. So we can do that for each of the columns we're interested in. However, we're wanting to do something a little more clever here. The address for the people in our file is stored as the street name and the town being the last part of this string. Now, while it's in one column in our file, we may want to split this up into two different fields in our database. For example, a street address and a city. So what we're going to do is we're going to pick up the street first of all before we populate the main user-defined type. So that will pick up the entire address field using our address column. And then we'll also store the same value in the city variable. So at this point in time, both the street and the city will have the same value. So what we can do for the street is we can quite happily use another function within our library called startRangeParse, and this will take all the values that are inside the strStreet variable that are comma delimited. It will count how many there are, for example 10, and it will take 1 away from them. Now we know in this case that the street will be 436 Long Road, Jonesville. So if we do a start range parse, there are two elements in here, the first element being the street address, the second element being the city. So using this start range parse function will give us back just the street address. So therefore our street will be happily populated. And for the city, we can use the parse command. The parse command has a very neat facility by which you can specify a minus number on the column, in which case it will start from the right hand side of the string and work backwards. So -1 would give you the last element of the string, delimited by the comma, which of course is our city. So now that we've sorted out the city, we can pull out the rest of the columns based on their column number, which gives us eye colour, blood group and email. Now, having done all that, we have now populated our user-defined type. So the next thing to do is to use a record pointer. Now, we haven't defined our record pointer yet, so let's just slot that one in. Our record pointer here is a quad, which will allow for some very big databases. And since it starts off as 0, we are incrementing it by 1. So the first time we run through this, it will become 1. And then to put our record into the database, it's a very simple put command. Put command with our file handle to our random access file, the record number, of which will be 1 for the first time we use it, and the name of the user-defined type we're firing out to there. And that is it. Our final instruction will be to close our input file. Now we're not closing the handle to the random access file because we're going to be continuing to use this. So we'll just try a quick compile to make sure we haven't missed anything. Yes, we have. We haven't defined the street yet. No, we haven't. Nor the city. So we'll just plug them in. So we try compiling that now. Yes, that's clean. It's always good to compile occasionally just to make sure that you haven't missed anything. So we go back to our routine. Since we're testing a true and false in this one, if for some reason we can't populate a database, there's no point in going any further forward. And we'll just put a little error message in. So we'll try running our program and we'll see what we get. Now at the moment there is no random access file sitting in here. So since we have compiled our program, we will try running it. And there is our dbcustomer.dat file. So now that we've actually populated that file, we can have a quick look at it in Notepad, and we'll see that there are indeed records sitting in there. So now that it's populated, we might want to put a few more functions in to determine how big the database is. We'll want to count the number of records in the database. So we're going to populate this total records variable to pull back how many records it put in. And we're going to create a new function whose sole task in life is to calculate how many records there are. All this will need is the database handle. So let's create this new function. And once we've actually created it, we will push the total number of records out to our log. So here's our new function with the single parameter, which is the database handle. We will just create two variables in here, one for the user-defined type and one for the size. Now, since we know the size of our user-defined type, and we can determine quite easily the size of the file, since the random access file is already open, we can do this in a single line. The size of the file is equal to the length of the file with the parameter of the database handle. This will return bytes, the total size of our file. And since we know the size of our user-defined type, the return is quite easily a straightforward bit of arithmetic. We take the size, and I'm doing an integer division here, divided by the length of the user-defined type. And with these two simple lines of code, this should tell us how many records we've got. So let's try running that and see what comes out. And the system now says there are 10 records in the database. So if we check with our original file to see if we had 10 records, and there we have effectively 11 lines, the top line which is the headers, and 10 data lines. So we have indeed put 10 records into the database. But are they correct? So what we'll do next is we will actually print out the records that we've actually put into our random access database. So we're going to read the whole database in. Now, since we've already pulled back the number of records, we can do a for next loop for a record count equals 1 to the total number of records, in this case which is 10. So we'll now need a function to get a specific record back from the database. So this will be another new function called getDBRecord. We'll pass this one 3 variables. We'll pass it the database handle, the record number we're interested in, and also a blank user-defined type which you can then populate with the data within that record. And the function will return a true or false. True if it can get the information, false if it cannot. So, one new function coming up. So there are our 3 parameters, the database handle, the record number, and our user-defined type, which we've defined previously. So again, we're going to use a try-catch block, and if anything goes wrong, we will return false. And if it works, we will return true. So in this case, we're going to use a get command. The get command with our database handle and our record number will return the information into this user-defined type. Now that's fine since we know we're reading exactly the number of records, but you want to put some testing in here to make sure we haven't got back a totally empty record. So we will prep a completely empty user-defined type at the beginning of our code. So uTestEmpty is defined as a UDT customers type. So since we're not populating it, we know that it will be empty. So what we can do is we can put an if statement in here to test if the record we have got back is equal to the empty one. If it's empty, then we'll return a false. If it's not empty, we'll return a true. And it's as easy as that. So if we look back at our code, if we return a true, then we want to put this out to our log. So since we're getting the full record back, we can decide what we display. Now if we just want to print out the names, we can do it this way. We can have an output variable equal to the customer first name, which as you'll remember is a 50-character field, plus the customer's surname. We're using the shrink command here, which saves you a bit of coding. It will take the 50 characters here, add a blank space between that and the next 50 characters, and then we can use the shrink command to remove everything but single spaces between words. So it will effectively trim this field, add on a single space, and then trim this field. And then we will push that out to our log. We'll say the record number is, for example, 1, and we'll say what the data is. So if we try running that now, we'll see there are our 10 records. We're pulling out the first name and the surname of each of the 10 records. And if we compare that to our original file, there is our original file, and we'll see that the names match. So it's pulling them out in the order we put them into the database, which is perfect. So say for example now we want to update a record. We want to change the value. So we'll need to specify which record number we're interested in. Now let's look down and we'll change the 9th one. We'll change this one. We want to change the customer's name in this one. So we'll set the record number to be record number 9. And first thing to do is to get the data back for that specific record. So we'll use the same command we used a moment ago, which will get our record back. Now we want to do an update on it. So just to be sure what we've got, we will print out the data. So we'll populate SCR output and then put it out to the log. So this should tell us we've got the right one. Let's just try running that. So there is our record 9 appearing at the end, and we want to change this particular customer's name. So if we get this far, we want to do an update. And we're going to change the first name of this customer just by updating the user-defined type. And we'll want a new function to actually save this updated record back to the database. So we'll create a new function called saveDBRecord. And again, like the ones previously, we're passing 3 parameters: the handle for our random access file, the record number we're updating, and we're passing back the entire user-defined type. Now we'll create that one in a moment, but on the assumption that it works, we will get the record again and put it out to the log. Exactly what we did before. Right, all we have to do now is to create this new function to save the database record. So again, just as we did, a new function with 3 parameters: the database handle, the record number, and the customer type. So again, we'll want another try-catch block. And if there's an error, we'll return false. Now all we need to do here is to find our record. So we're going to use the seek command to seek out the record number. Only takes 2 parameters: the file handle for the random access file and the record number. And then we're using a straightforward put to put it to that. Now in theory you wouldn't need the seek command, the put command would do, but if the seek command errors, then it will trip and jump into the catch block. And if the put fails to write, it will also jump in there as well. So having done that, let's try running. And there we see our first 10 records coming out quite happily. Record 9 is returning as Denise Finlay, and record 9, having been updated, is now returning as Samantha Finlay. So we have successfully updated record 9. Now we can quite happily add a brand new record from inside our program. So let's set up to add a brand new record. Go down here, and this is where we will add a brand new record. Now since we know the total number of records in the database is 10, we'll make our new record number 11. And we can use the prefix command again to specify the user-defined type, and we can populate it with some new information. Now this could be information the user themselves has actually keyed on the screen in another form, and we're going to put this into our database. So we can use the command we created earlier to save the database record to the file. And if this does return a true, we can get the database record coming back, and we can display this on the screen. So we'll do exactly the same as we did before to print the names out to the log. So we've populated our user-defined type, we've saved the record to the database, we've got the record back from the database to make sure it's coming back correctly, and we're going to print it out to the log. And just to be sure, we're also going to print out the number of records in the database to see how many are coming back now. So we should have increased the number of records in the database. So again, we're using the getDBRecordCount function we created earlier. So there we go, there's our James Smith being added as record number 11. And the program is now telling us there are in fact 11 records in the database, which is quite correct. Now, if we attempted to read beyond the end of the database, would that work? So let's set our record number to record number 12. We know that record number 12 doesn't exist, and we'll try and do a getDBRecord from there, using the function we created earlier to get a DB record. If it returns true, we can say we actually managed to succeed in getting record number 12. If it returns false, it will say we didn't get the record. And just to tidy up at the end of the program, we want a function to close down the database. Now this would automatically happen at the end of the program anyway, but there may be points within your code where you want to close the database. So we'll create our close database command first. This will only need a single parameter, which will be the database handle. And here is the skeleton. This is going to be a very simple function. All it's going to do is just close down the handle. A simple one-liner. So what we're doing here is we're going to try and read the 12th record, which should not succeed. If we run that now, it tells you it cannot get that record. Perhaps we want to improve that slightly, and we will add on which record we were trying to get. That's better. So what we've done today is we've created a random access database from a flat text file, which was tab delimited. We have added new records to the database, we have updated records within the database, and we've checked to see how many records are in the database. The only thing we haven't done is to remove records from the database. Now, depending how you want your code to work, there are a number of different ways of actually doing this. Now, you could update the record in the database and put in a completely empty user-defined type. That would effectively blank out that record. Or you could have one field in your database which marks the record as either being active or inactive. This would depend entirely on how you want to run your database. But this has been a short introduction to random access files. That's it for today. Thank you for watching.